3D printers create physical objects by printing layer by layer directly from digital files. The printer that you are viewing is what is called a fused deposition modeling, or FDM printer. It prints three-dimensional models using ABS, more commonly known as ABS plastic. It is a tough, low-cost thermoplastic. For 3D printers, the plastic is shaped like a filament and is wound on spools. That plastic filament is heated, and the printer moves back and forth depositing the plastic. As layers are added, the base lowers. In 2014, a 3D printer was successfully installed on the International Space Station, or ISS. The ISS 3D printer created a faceplate of the extruder's casing for its first print job, according to NASA's website. Werkheiser, the project manager for the ISS 3D printer, said the team selected this part for its first print because the machine needs to be able to print spare parts for itself if astronauts will be relying on it to make spare and replacement parts for critical items in space. Bringing supplies to astronauts on the International Space Station can be a little challenging, leaving astronauts waiting for the next costly and risky supply mission. On the left side of this exhibit, you will see a 3D printed wrench. It is identical to the ratcheting socket wrench that was the first uplink tool printed in space. The tool was designed on the ground, emailed to the space station, and then 3D printed. ABS plastic is not the only material that can be used in 3D printing. Other materials include stainless steel, sterling silver, brass, bronze, ceramics, rubber, human tissue for organs, food, cloth, and makeup. Cornell Creative Machines Lab announced in 2012 that it was possible to produce customized food with 3D hydrocolloid printing. Additive manufacturing of food is currently being developed by squeezing out food layer by layer into three-dimensional objects. A large variety of foods are appropriate candidates, such as chocolate and candy, and flat foods such as crackers, pasta, and pizza. As the costs of 3D printers have come down, they are becoming more appealing financially to use for self-manufacturing of personal products. In addition, 3D printing products at home may reduce the environmental impacts of manufacturing by reducing material use and distribution impacts. In addition, several recycle bots, such as the commercialized Philistruder, have been designed and fabricated to convert waste plastic, such as shampoo containers and milk jugs, into inexpensive rip-wrap filament. There is some evidence that using this approach of distributed recycling is better for the environment. In May of 2015, Airbus announced that its new Airbus A350XWB included over 1,000 components manufactured by 3D printing. A good example of 3D printing in construction is Dr. Koshefnis's research at the University of Southern California, which resulted in a 3D printer that can build a house in 24 hours. Furthermore, the CenterHab project is researching a lunar base constructed by 3D printing using lunar regolith as a base material. Instead of adding a binding agent to the regolith, researchers are experimenting with microwave sintering to create solid blocks from the raw material. The hand that you see in this display is a product of Enable Columbus, a community service and educational project sponsored by the Coca-Cola Space Science Center in collaboration with the Muskogee County School District. The program focuses on 3D printing and enables students to use 21st century tools to fabricate prostheses for local members of the community. This is done at no cost. Students apply knowledge acquired in the classroom to connect to a real-world need. Additional information on Enable Columbus may be found at enablecolumbus.org.